Breadth-first search is like going layer by layer through a graph, exploring all nodes at the current depth before moving deeper. Let's learn how breadth-first search, or BFS, works, using both the concept and a practical example side by side. We begin with a graph, and to perform BFS, we'll need two key tools: a queue to manage the order in which we visit nodes, and a visited list to track which nodes we've already seen. Let's say we're starting at node 1. First, we place node 1 into the queue and also mark it as visited. Now we enter a while loop. This loop continues until the queue is empty, or until all nodes in the graph have been visited. We remove node 1 from the queue. Its neighbors are 2, 3, and 5, none of which we've visited yet. Add 2, 3, and 5 to the queue and mark them as visited. We take the next node from the queue, that's 2. Its only unvisited neighbor is 6. We enqueue 6 and mark it as visited. Next in the queue is 3. It connects to 8 and 9, both unvisited. We enqueue 8 and 9 and mark them as visited. Step 4, we move on to 5, which connects to 7. We enqueue 7 and mark it as visited. Step 5, now we process 6, which connects to 4. We enqueue 4 and mark it as visited. At this point, the visited list contains all nodes in the graph, and the queue becomes empty. That means our BFS traversal is complete. This layer-by-layer approach is what makes BFS so effective for finding the shortest path in unweighted graphs. In the next video, we'll write the actual Java code for this process step by step. Thanks for watching, and see you next time.